Hello students, today I am going to start the second chapter of your class 7 syllabus, that is motion. Okay, so to understand motion, you first need to understand what is rest. Okay, so what is rest? Can you see this book is lying on the table? Okay, now if anybody asks you the book, what is the state of the book? Is it at rest or motion? You will say that the book is at rest, right? So a body is said to be at rest if it does not change its position with respect to a fixed point, okay, with respect to its immediate surrounding, okay, then the body is said to be at rest. For example, the book lying on the table is at rest. A bench fixed under a tree, this is at rest with respect to its immediate surrounding. So always remember, whenever the position of a body with respect to its surrounding does not change with time, the body is said to be at rest. I hope it is clear to you. Now let's move on to our next. So next is motion. When we have already talked about what is rest, we already know when a body does not change its position with respect to its immediate surrounding, then the body is said to be at rest. Then how can we define motion? Now motion, if the body changes its position with respect to its immediate surrounding, the body is said to be in motion. For example, you can see this flying bird, it is in motion. Can you see this man walking? He is in motion. Can you see the school bus moving on the road? So the school bus is in motion. Is it clear? So this is motion. Now, you must have always heard that rest and motion are relative terms. Now, student, what do you mean by this? Now, you see, just look at the school bus. If you look at the school bus, you see a number of people is sitting on the school bus. Let us name this boy as A. Okay, and let us name this boy as B. And let us name this another boy as C. Okay, now if you ask C the state of A, what will C say? C will say that A is at rest. What will C say? C will say that A is at rest. All right, is it clear? But if you ask the boy B that tell me the state of A, according to B, the A state of A will be motion, in motion. So you see the same object A, according to C it is at rest, and according to B it is in motion. And that is why we say that rest and motion are relative terms. An object is in motion with respect to a set of objects, but at the same time it may be in a state of rest with respect to other objects. Clear? Shall I give you one more example? Suppose this is earth. Okay, what all is there on earth? Trees, buildings, etc., man, etc. Okay, and suppose this is moon. Now if an astronaut is on moon, and the astronaut views the earth. According to this astronaut, the earth is moving, right? Now because the earth is moving, therefore according to the astronaut, the trees, the building, the man, they all are in motion. They all are in motion. But if you ask this man whether the building is in motion or at rest, whether the tree is at rest or motion, what will this man say? He will say that the tree and the building, they all are at rest. So the same object is at rest due to with respect to one person, and with respect to another person it is in motion, and that is why we can say that rest and motion are relative terms. I hope it is clear to you all. Now let us move ahead. Now, types of motion. If you go through your book, there are many types of motion mentioned. Okay, so we will see all of them one by one. Number one is translatory motion. What is translatory motion? If an object like a vehicle moves in a line such that every point of the object moves through the same distance in the same time, okay, then we call such motion as a translatory motion. For example, there are two kinds of translatory motion. One is rectilinear motion and the other is curvilinear motion. You see that the man is moving in a straight line. Then the motion executed by this man is said to be rectilinear motion. So what is rectilinear motion, students? If an object moves along a straight line, the kind of motion is called rectilinear motion. Now coming to the curvilinear motion. As you can see that this man, or this cartoon rather, is throwing ball in a curved path, somewhat like this. The path of the ball is a curved path. Okay, so whenever the object moves along the curved or a circular path, we call or we define such motion as curvilinear motion. I hope it is clear. So translatory motion is of two types, rectilinear motion and curvilinear motion. Okay, now coming to our second type of motion, that is rotatory motion. Okay, now what is rotatory motion? A body is said to be in rotatory motion or circular motion if it moves about a fixed axis without changing the radius of its motion. Okay, it moves about a fixed axis without changing the radius of its motion, just like a ceiling fan, just like a spinning top. Okay, so if anybody asks you, give few examples of rotatory motion, what are you going to give? Spinning top and ceiling fan. Even table fan is an example of rotatory motion. We can have multiple examples of rotatory motion. Suppose a stone is tied with the help of a string and it is whirled in a circular manner. So it moves about this fixed axis without changing its radius. Is it clear? So therefore, this is the kind of motion which the stone is exhibiting is rotatory motion. Now let us see what is oscillatory motion. The to and fro motion of an object about its mean position is called oscillatory motion. Now many students face difficulty in understanding oscillatory motion. Look very carefully into the pendulum of this clock. Suppose this is the bob and it is oscillating like this. Okay, so this position is called the mean position. Okay, and the bob goes to and fro from the mean position. Then such motion is called oscillatory motion. Two best example of oscillatory motion is the boy on a swing, the pendulum of a clock. Okay, so now let's move on to the next category of motion, that is the periodic motion. Now what is periodic motion, students? A motion which repeats itself at regular interval of time is called periodic motion. Just now we studied that the pendulum of a clock is oscillatory motion. Now you will say, ma'am, you have mentioned that this is an oscillatory motion. Then how can this be a periodic motion? Yes, it is possible because this to and fro, this oscillatory motion repeats itself at regular intervals, and then we term it as periodic motion. Whatever kind of motion repeat itself at regular interval, we call it a periodic motion, just like the needle of the sewing machine. Okay, this is also a periodic motion, needle of a sewing machine. Alright, next what do we have? We have the earth rotating around the sun. So this is also a periodic motion, because after every one rotation, what do we have? We have a new year, right? So remember students that all the motion that repeat itself at regular interval of time is called a periodic motion. So now let's move on to the next topic. Okay, so now we have uniform and non-uniform motion. Students, what is uniform and non-uniform motion? Have you ever heard this term before? No? Then don't worry, because I'm going to explain it to you in a way that it will be super duper clear to you. So let us first see what is uniform motion. Now first let us read the definition of uniform motion. If an object covers equal distance in equal interval of time, we say that the object is in uniform motion. Remember, the object has to cover equal distances in equal interval of time to be in uniform motion. Okay, when the motion is uniform, the body remains at constant speed throughout the period of its journey. For example, you came out on your bicycle, okay, and you went out for a ride, and you drove your bicycle with a speed of 20 kilometer per hour, okay, and you drove with this speed till you started from point A till point B. You continuously drove your bicycle, you rode your bicycle with this speed 20 kilometer per hour. That means you did not change your speed, it was a constant speed. Therefore, the motion of your bicycle was a uniform motion. I hope it is clear to you. Now let us move on to non-uniform motion. If an object does not cover equal distances in equal interval of time, unlike the uniform motion, in uniform motion, equal distance in equal interval of time. Over here, unequal distances in equal interval of time. Okay, over here it does not cover equal distances in equal interval of time. Then it is said to be non-uniform motion. When motion is non-uniform, the body moves with variable speed throughout its journey. That means suppose you started with 20 kilometer per hour, but after some time, suppose 5 minutes, you changed the speed to 10 kilometer per hour. Again after 5 minutes, you changed the speed to 15 kilometer per hour. So you are continuously changing your speed, right? That this is called variable speed. It is not constant, it is not uniform, it is variable speed. So whenever an object or a body moves with a variable speed, a non-uniform speed, then the motion is termed as non-uniform motion. I hope it's clear to you all. Now let us move on to an example of uniform motion. Can you see this chart, students? Over here in the first column, it is given, the time is given to you. In the second column, the time taken by the object or a cycle or a car, whatever, is given to you. And then this is the total distance which is covered in this particular time. Okay, and here we are calculating the distance covered in equal interval of time. Alright, so you see at 1 o'clock there was no distance covered, there was no time taken, the distance covered was 0. At 1:05 p.m., that means after 5 minutes, the total distance covered was 5 kilometer. Then at 1:10 p.m., that is again after 5 minutes, the distance covered was 10 kilometer. Then 1:15 p.m., again after 5 minutes, the distance covered was 15 kilometer. And same way you can see all the readings. So here we are calculating how much distance is calculated in every 5 minutes. So you see in 5 minutes of time from 1 to 1:05. How much distance is calculated? At 1 o'clock the distance was 0. At 1:05 the distance is 5. So 5 minus 0, that is 5 kilometer. Now you see in the next one, from 1:05 to 1:10. At 1:05 the distance was 5. And at 1:10 the distance was 10. So in 5 minutes the distance became 10 minus 5, that is again 5 kilometer. Likewise, if you calculate for each and every 5 minutes, you see you will get 5 kilometer, 5 kilometer, 5 kilometer. All the readings will be same. That means equal distance is covered. Equal distance is covered in equal interval of time. In equal interval of time, that means in 5 minutes. So such a motion is known as uniform motion. Such a motion is known as uniform motion. Student, if you face any problem or doubts in understanding this example, you can always mention it in the comment section. I will explain it to you properly. Okay, now let's move on to the next example of non-uniform motion. You see, we again have the same set of times, okay, and the distances covered in this particular time. So again we calculate the distance covered in equal interval. That means we see in every 5 minutes how much distance is covered. So from 1 o'clock to 1:05 p.m. how much distance is covered? 5 minus 0, that is 5. Now from 1:05 p.m. to 1:10 p.m. how much distance is covered? 9 minus 5, that is 4. Now from 1:15 to 1:10 to 1:15 p.m. how much distance is covered? 14 minus 9, that is 5. So you see at every 5 minutes different distances are covered. Unequal distances are covered in equal intervals of time. Unequal distances are covered in equal intervals of time, that is in 5 minutes, right? So we call such motion as non-uniform motion. Okay, whenever unequal distances are covered in equal intervals of time, such motion is known as non-uniform motion. Okay, now let us move on to scalar and vector quantity. Now this is a new topic which is introduced to you. Okay, so student, always remember every physical quantity is categorized under two types. One is scalar quantity and the other is vector quantity. Now what is a scalar quantity? Scalar quantity, a physical quantity which has only magnitude. It has no specific direction. Then such a physical quantity is called a scalar quantity. Now you may have problem understanding what is magnitude. Students, let us take an example. Suppose mass. Okay, you went to buy grocery with your mom and you bought 2 kgs potato. What you got? 2 kgs potato, right? So what is 2? 2 is the magnitude. 2 is the value. How much potato you got? The value. And kg is the unit. So how much you got? 2 kg. What you got? Potato. So 2 is the magnitude. So always remember a physical quantity which has only magnitude and no specific direction. Is there any direction mentioned over here? East, west, north, south, anything, any direction? No, that means this is a scalar quantity. Whenever a physical quantity has only magnitude and no direction, then such a physical quantity is termed as scalar quantity. Example, length, distance, volume, mass, just like we discussed right now, time, energy, temperature. When we get fever, right? We have chills. Our parents check our temperature, right? 98 degree Fahrenheit. Do they say 98 degree Fahrenheit in the west direction? No. What do they say? 98 degree Fahrenheit. That means the temperature has only magnitude, no direction. There is only magnitude. Therefore, temperature is a scalar quantity. Now coming to the vector quantity. What is a vector quantity? A physical quantity which has both magnitude and a specific direction is called a vector quantity. For example, displacement, velocity, acceleration, force, weight, they all are vector quantity. Let us understand this in a little detail. For example, we talk about weight. Okay, we all have weight, right? Suppose this is a body. Its weight will always act in vertically downward direction, mg. Always remember, weight always acts in the vertically downward direction. So suppose a body has a weight of 10 kgf. Okay, so this is the magnitude and the direction will be in the downward direction. So a physical quantity which has both magnitude, it has magnitude as well as direction, right? As well as direction, then such a physical quantity is termed as vector quantity. So next time anybody asks you about vector quantity, I'm sure you're gonna answer it correctly, right? So what is a vector quantity, students? Let us repeat once again. A quantity which has both magnitude and a specific direction. Let us take another example. Suppose force. Now you tell your friend that I apply a force of 10 Newton. Now how is the force applied? Suppose this is a wall and you are applying a force of 10 Newton on the wall. But how you are applying, it is not clear. You can apply in this way, you can apply in this way, you can apply in this way, you can apply in this way. There are multiple ways in which you can apply the force on a wall. So this is an incomplete information. You have to mention the direction also. You have to mention the direction also. So every physical quantity which has magnitude as well as direction is known as a vector quantity. I hope it is clear to you. So this is the part 1 lesson of your chapter motion. I will come up with the next part of the chapter soon, and we will also cover each and every question which is given at the back of your book. Parents and guardians are requested to please mention their queries in the comment section so that I can help you at the maximum way possible during the current lockdown. Thank you all. Take care and stay safe.